We're on page 97 of the notes, section 6.4. We're going to talk about the properties of logarithms, some of the really interesting things that you can do with logs that are very unique to pretty much anything in math. What you're asked to do in 1A and in 1B is to put a natural log thing in the calculator. How about that? So they want you to put natural log of 7 times 2, and then the natural log of 7 plus the natural log of 2. They're also asking you for 2a and 2b to do the same thing. So I want you to pause right now and go into Desmos and do all 4 of these in a calculator and come back and compare what you've got with what I'm getting. Go ahead and pause right now. Okay, so bringing in what I have for my calculator, here is the things from my calculator. Natural log of 7 times 2, the result from that was 2.639 if I round it to 3 places. The natural log, or I'm sorry, the regular log of 8 times 3 is 1.380. If you go in and look at natural log of 7 plus the natural log of 2, I get 2.639, and the natural log, or the regular log of 8 plus log of 3 is 1.380. I want you, obviously, to take note and observe what's going on here, that if I were to multiply 7 times 2 in front of the natural log, or if I was to break it up and add the natural log of 7 plus the natural log of 2, you're going to get the same answer. Same thing with 2a and 2b. Same idea. Notice it works for natural logs and regular logs. So that's a thing. Really interesting. Now I want you to go ahead in your calculator and you're going to again evaluate 1a, 1b, 2a, 2b. I bet you have a feeling of what's going to happen, but I still want you to pause and go ahead and do that and come back and check what you've got with me. So go ahead and pause now. Okay, so I went ahead and went to my calculator. Let me bring in my results for all 4 of these. I know that they're in kind of a different order, but that's okay. Here we go. Putting it over here. The natural log of 45 divided by 5 is 2.197. Then the log of 30 divided by 6 is 0.699. The log of 30 minus the log of 6 is 0.699. And then the natural log of 45 minus the natural log of 5 is 2.197. Notice again, if I am dividing, I'm taking the quotient next to the log. I can also write that in a way, if I were to take each of the pieces of my quotient and separate them into their own log, and I subtracted them, I would get the same answer. The activity in number 1 is an example of the product property of logarithms. And the activity we did in number 2 is an example of the quotient property of logarithms. Interesting, right? I have down here on the end of this first page of notes the little blip of the formal way that they would show you this in a textbook, which is exactly like what we did above, but that's the little write-up that they would give you as a formal definition of what the product property for logs is. Let's go to the next page. And we are going to talk about expanding the following logarithms. So we'll talk about that in a minute. I also have, just so you know, the quotient property for logs on here also. Okay, so if you're expanding the logs, that means that you're rewriting them. So expand means you're going to rewrite, and expanding is implying that your sentence is going to get longer. But just remember that if you see multiplying here, that multiplying means that when you're expanding, you get to start doing addition symbols. So if I was going to expand a, it would look like the natural log of 5 plus the natural log of 17. I expanded that just like we saw on the page before. If I was going to expand b, notice that there's not 1, not 2, but there's 3 factors inside there. I would expand that by breaking them up into each of their own log base 4s. So B would be log base 4 of 13 plus, because these are being multiplied, log base 4 of x plus log base 4 of y. 3 factors means 3 terms when I expand. Same kind of idea if you're asked to expand things that are being divided. Now, I'm going to do B first. Remember that the quotient property states that if you have a quotient inside your parentheses with your log, you can break it up into their own separate logs with the top divided by the bottom. So if I was doing B, it would look like this. Log of 35 minus the log of 8. Simple as that, right? What happens if you have something like A? Because A has, not only am I dividing, but on the top I'm multiplying. And remember, when we're talking about multiplying, we are adding. So A would look like this. Log base 5 of m plus the log base 5 of n, because those are being multiplied. And then this is going to be quotient property. So in order to put 9 on the bottom, I'm going to say minus log base 5 of 9. So this tells me that we have a multiplying thing happening here, and that we have a division thing happening here. Go ahead and try A and B on the very bottom. Pause the video, come back, and you can compare your answers with mine. Take a moment right now and pause. For A, natural log of 5 plus the natural log of A plus the natural log of B. They're all being multiplied. For B, we have the log of 7 plus the log of n minus the log of m. Every time it has everything to do with what you're doing, multiplying or dividing. Let's go to the next page. If you're expected to expand, then you should also be able to unexpand. For instance, you now know that adding and multiplying go hand in hand when we're expanding or not expanding logs or natural logs. So for A, since I have an addition sign here, this means I could combine these and write these as a single log, and I would just have to put a multiplication symbol inside my parentheses, and I could actually take that one step further and say the result here is a log of 56. What about B? So we're adding again. So this is a natural log of x plus 2 times x plus 5. On WebAssign, they would probably force you to FOIL that or double distribute. So they probably would want you to write the natural log of x squared plus 7x plus 10, which is when we multiply those out. It's possible that they might not make you do it, but if they do, you're prepared. For C, we have the natural log, open up parentheses, 3x over 5z, because this is a subtraction symbol that goes with dividing. And for D, I have log base 7, open parentheses, 2m over n. I want you to take a moment and do the 3 examples that we have here at the bottom of the page. Pause your screen and come back and check your answers with me. So you're going to pause now. Okay, so let's look at the very first example. I have the natural log, open parentheses, 18s over 3t. The only thing is, once I put this in a quotient form, I realize I can simplify some of this and actually write this as 6s over t. For B, we have lots of multiplying going on. We have the log base 7 of 5 times m times 3n, and I can simplify this and make this 15mn. The third one, log base 10, we won't write that, x plus 3 times x minus 7. Be prepared to multiply those out to have the log of x squared minus 4x minus 21. Okay, let's go to the next page. And let's talk about the power property. This is the one section, 6.4. A lot of people look at this beforehand and they think that this is going to be the most challenging part of Chapter 6, and then they are so pleasantly surprised at how doable and not as challenging as they thought it was going to be, it ends up being. This is what the power property says. If you have the log or the natural log of some base, and you'll have something next to it that has a exponent, you can rewrite that with the exponent out front. For instance, if you have log base 3 of n squared, you can take this squared and put it out front. And you could write this as 2 times log base 3 of n. That's what the power property is for logs. It's really nice. It's a way of getting an exponent out of the exponent spot, and that's kind of important sometimes. So if I was going to expand a, there are 2 factors here. The first one is 5, so I'm going to write natural log of 5. The second one is x squared, but I'm going to take the 2 and put it in front and say 2 natural log of x, because I took this 2 and I brought it down and in front, and that's what the power property says that I can do. I can do it anywhere that there's an exponent. So for b, I have log of 2 plus, because there's multiplying, 3 log of x minus log of 5. Again, remember that a 3 was the exponent. I could bring it out in front of the whole term. C, log base 4 of 9 plus 3 log base 4 of x plus 2 log base 4 of y. These 3 and 2 come from the exponent spot. And the power property says I can bring it out in front, which is what I want to do. You would think that these are getting worse and worse, but I promise they're not. It's not too bad. For D, all I know here is I'm going to have 4 terms because there's 4 things going on in there. 2 factors on top, 2 factors on bottom. I also know that there's 3 terms that have exponents that I'm going to have to pull out front, and I'm getting ready for that. So the first term here, 2 log base 5 of m. That was me dealing with this one. Plus 5 log base 5 of n. Dealt with that one. Minus log base 5 of 2. Dealt with that one. Plus 3 log base 5 of z. 4 terms, 4 pieces. Got it all. Don't forget, okay, so I'm moving on from D. E. Remember that when you have a square root symbol, you can write that as a power of 1/2. You can do that. I don't know why I put that so far over. These things should be squished together. I should put that back over there. Now I'm going to expand this, so I'm going to say log of, oops, I'm sorry. Let's erase because I didn't address the fact that 1/2 goes with each piece of there. 1/2 log 5 plus 1/2 log x plus 1/2 log y. There is another way to write this. You could have just put 1/2 and then put the log of 5 plus log of x plus log of y all in a set of parentheses. Either or, both of those shall work. But that is how you expand. And just like the other expanding, you should be able to unexpand. So I'm looking here. I see multiply. I see multiply. I see I have exponents going on. So I'm going to rewrite this as log of 8x cubed y to the 4th. If you don't know where those things came from, you're going to want to pause it and really look at this. Just remember this 3 is here. This 4 is here. So that's really important to understand the product or the power property. For B, natural log, I have multiplying, I have dividing. I have an exponent here. I have an exponent. What do I got going on here? There must be some multiplying in there that I didn't even see. Oh, no, there's none. I'm sorry. I see natural log. Okay. That's the only exponent. Okay, so let's start this out. Natural log of 3, and then it looks like 5a squared divided by b. Okay, so that's really weird how they wrote that, and you won't see that very much. But 5a is together. And so this actually is worth 25a squared. 5a times 5a is 25a squared. And 25 times 3 is 75. So natural log of 75, a squared over b. Holy Hannah, that was ugly. I want you to pause up and do C and D, and then come back and check your answers with me. And go ahead and pause now. Okay, for C, I have dividing, I have multiplying, I have a power, another power. So I have natural log, open parentheses, x divided by z to the 5th times y squared. And D, I have log base 7 of 2 times m over n cubed times 5, which is weird because I like to put that 5 out front, so I'm actually going to rewrite this. 2m over 5n cubed. There we go. Beautiful. Okay, let's look at the last page of this video. Okay, so this is one of those awesome situations where you're going to want to pay close attention. It could be really difficult if you are kind of spacing out right now. So this is kind of like a logic question. It says if log base b of 2 is equal to 3 and log base b of 16 is equal to 4, then I need to find log base b of 32. This is what I'm going to do. I'm actually going to look at what's happening in this spot, and in the other two, this is what's happening in that same spot, right? And I want to find the relationship between these two numbers and this number if I can. And there is a relationship, basically, is that I can rewrite 32 as 2 times 16, right? I could say that, oops, I don't want it to be in red. I could say that log base b of 32 is the same thing as log base b of 2 times 16, right? And I also can say that I can expand this and make this log base b of 2 plus log base b of 16, because we know the product rule, and the product rules we can expand it. Well, it just so happens that they've told us that the log base b of 2 is 3. And they've told us that the log base b of 16 is 4. So 3 plus 4 is 7. And so I can say that the log base b of 32 is 7. Crazy, right? I want you to watch that again to understand what I'm coming from, because I expect that you're going to be able to try the second example on your own. So go ahead and pause. Second example, that's what you're doing. Same exact thing. I want you to do it and find what the log base b of 8 is. Pause now. Okay, I am looking at the relationship here between what is in that spot, what is in the spots for here and here. Notice these all are the same spots. I have 3 different logs. I have 8, which is what my end result, and I have 2 and 16. I need to figure out what the relationship is between 2 and 16 and 8. And basically, 16 divided by 2 is 8, right? So I could take my log base b of 8, and I could rewrite it as log base b of 16 divided by 2. And then I have the quotient property, so if I wanted to, I could separate this out and say log base b of 16 minus the log base b of 2. And then I know that the log base b of 2 is equal to 3, and the log base b of 16 is equal to 4, and 4 minus 3 is 1. So the log base b of 8 must be 1. Okay, so you're going to want to get started on your homework, and hopefully if you have questions, you know your resources and how to get a hold of people or myself to answer some questions. Other than that, good luck.